Hello everyone, in this video we are going to understand like our prototype and how we are going to implement the given problem statement ID 1617. So our problem statement suggests that the DTC buses are majorly facing the three issues, and they are namely the rerouting part. Rerouting we mean the routes which they are following are not the optimal in the way of carbon emission and all of those things. And also apart from this, the one more issue which they are facing is the dynamic scheduling. From dynamic scheduling, I mean like if there are two places. In one place there are lot of demand of buses. So if they want to send buses there, so they have to do all of these things manually. And apart from this, there also one more thing like crew management. They are unable to manage their crew efficiently. So we have made the prototype for them at the admin panel end. So what our prototype focuses on? So our prototype mainly focuses on all of these three issues. So let's address all the issues one by one. So starting with the first issues, like the rerouting of the buses. So what we have implemented, like we have extracted all the routes from the given data set. For example, we have 477 routes and almost there are 7,000 bus stops in between, and all of them are covered by the DTC buses. So like how we rerouted them. For example, if it is a source node, I can consider it is a source node and it is a destination node for the one of the 477 routes. So if we consider only one source and one destination for the 477 routes, and for example if this route have for example 8 destination points like this, like it has 8 stops. So what we have done, like we have different routes for all the different stops for all the routes. So what we have did, like for example if this had 8 stops, so we have considered it as a node, like it as a node of the graph. And what we did, like once we have considered it as the node of the graph, and there are also, like for example there could be the A1 route and source and B2 destination for the route 2. So we didn't consider it as the source and the destination, but we have considered the stops of it. Like if it has one stop, it has another stop like this. So what we have did, like we have implemented the geocoding. So once we have extracted the latitude and longitude from the given path, so for example I have the latitude and longitude. So by using the geocoding method or by using the geo maps, I can locate all the spots in the given map of the DTC buses. So what I will do with it, like what our main idea is of doing it. There is a formula called Hackathon formula. So what does it mean? Hackathon formula, it is a formula which take latitude 1 and longitude as the parameter. So if I have the Hackathon formula, it takes latitude and longitude as a parameter and it calculates the distance between any two nodes. For example, if it is a source node and it is one of the stop. So if I need to know like how many kilometer at how many kilometer distance it is from the source node, so I can calculate it using the Hackathon formula because I have extracted the latitude and longitude. So for example, I get 4 km from here and namely 4 km, and if I sum up it till here, so it came around 60 km, and my number of stops in between is 8. So what I am doing, I am taking the number of stops 8 only, but what I am trying to do, like if I get anything less than, using the we have implemented here the Dijkstra algorithm to find the shortest path between any nodes. So if I get, like for example there is one more node and here 2 more nodes are there, so I go here, and then here. I have covered the 8 destinations, and the sum up till here, it came out to be 56 kilometers. So like it is more optimal and it got rerouted. And it is also like we are also taking care of the carbon emission and all of those things. So it is the rough part, like what we are doing in rerouting. And if I talk about the dynamic scheduling, so we have got the data set of routes and like how many buses are there from the given DTC portal or any other things like that. So we have built an ML pipeline for that. Like we have created ML pipeline for namely five parameters having the 18 hours of work. For example, if there is a time between 4 to 6 and then 8 to 10, we have created the model on the basis of 2 to hour interval. Like we have to get the how I can schedule in those hours on the basis of the necessity in any particular region. So for example, in between 4 to 6 hours, the number of requirement is obviously going to be bit low, and in 8 to 10, as it is a working hour, the number of requirement is going to be very more. So like we have implemented all of this data set using ML model, and after that we have written two functions, namely, for example, if there are 10 buses and each bus has the capacity of 60, so like maximum it can hold 600 people. So for our hypothesis, what we did, like if there is a route, like if there are 540 people only going to that route using 10 buses. So see here and the buses are coming in the frequency of 10 minutes. Like this is the current frequency. We can denote it using CF, current frequency. So see here the number of people are getting reduced. Like this demand in that region is getting reduced. So I should be increasing the number of frequency. So how I am doing that? We have simply derived a formula for this, like 600 by 100 and then 540 by 100, and we are taking floor of it. And how I am deciding, like I will be taking floor or still, it depends on my baseline density. Like it is also my baseline density, like it is the topmost parameter through which I am comparing. So it will come out to be 6 and it will come out to be 5. So what I am doing, like if the number of people are getting reduced from baseline, so I will add time in the current frequency, like this current frequency plus this is my baseline density, which is 6, this is my current density, which is 5, so and this was 10, so 10 plus 1, it will be 11. So here frequency is getting increased. And similarly we can do in the case of otherwise too, like if the number of people in place of 540 we are having 660. So in this case we would take CL of it and we will minus it from here. So it is basically about the dynamic scheduling part. And apart from this, we have also managed the crew, and for that purpose we have basically created a two data structure like this. We have used two queue. This is active queue and this is the passive, or we can say rest queue. Like for example, for this purpose also we have created many math formula. For example, as we are starting from the 4 p.m. so I have some baseline as 240 minutes. Like I can rest them or take them into the work after the 240 minute only, like from 4 p.m. only. So what we did here, for example, if there is a pair of driver and conductor and they were on work since 4 hours. So what they will be doing, like see during the survey period, like during the period in which they are serving, so they will be in the active queue here, and once they have served the particular 4 to 5 hours of work, then they will be went directly to the resting queue here. And in this queue what they will be doing, like there we have created here the parameter of 60 minutes. Like for example, if they are in the resting queue, so they won't be there more than 60 minutes. Like for example, if there is a pair of bus driver and bus conductor, like it is a pair and they have served for 4 hours, so they will directly went to the resting queue. And we have also implemented it for the linked and unlinked data. So this is it from our side, and also we can also increase the efficiency in the dynamic scheduling part by dividing the timeline into the chunks. And apart from this, we have additionally also implemented one more feature, like how we can maintenance bus on the basis of its engine oil level and various parameters. And we have integrated blockchain in that. Like we are storing our each and every prediction in the transaction hash key. So this is it for the given problem statement. Thank you.